Hi guys, Mr. Thompson again. Today we're covering Lesson 5, Session 3, which will be pages 93 through 96 in your Ready textbook. All right, today, our learning targets, we're going to refine strategies for solving multi-step problems involving proportional relationships, as well as refine our understanding of proportional relationships. So, that's a little brain warm-up for today. Think about this problem and see if you can solve it. A recipe for 4 servings of pudding calls for 2/3 of a cup of cream. How much cream is needed for 12 servings? Spend a few minutes on that, see what you come up with, and when you come back, we'll check your work. Okay, welcome back. Let's take a look at what we were finding here. We know that we have a ratio of 4 servings per 2/3 of a cup. Now, we're looking for how much cream for 12 servings. So we're looking for our answer in terms of how much cream per serving. So let's set up our ratio as cream per 1 serving, and then multiply that by 12 to get 12 servings. So if we have cream over pudding, like this, we know we have 2/3 cup of cream per 4 servings. So to find out how much is that per 1 serving, we can divide to find out the unit rate. But notice that we have a relationship between the 4 servings it's given us and the 12 servings that we're looking for. 4 is a nice even multiple of 12. So instead of going down to the unit rate, let's just work this like equivalent fractions and work it across that way. So if we have 4 servings of pudding, we multiply that times 3, and that gives us 12 servings. So if we have 2/3 of a cup of cream, we multiply that times 3. 2/3 times 3 is 2/3 times 3 over 1. Those 3's cancel. We can cross simplify that. And that gives us 2 over 1, or 2 cups of cream per 12 servings of pudding. So how'd you do? So open up in your textbook to page 93, and let's look at this example that it gives us at the top of the page. We'll talk about that, and then work out these questions one by one, see how you do. Okay, here's our example. In the student council election, 217 students are voting. Uma receives 4 votes for every 3 that Paloma receives. How many more votes does Uma receive than Paloma? So the first thing we have to do is find out how many of those 217 votes each of them gets. And to do that, you see we have to find 2 proportions and solve for the total number of students. Now you'll notice that we have 7s here, 4 over 7, 3 over 7. Why is this? Well, it's because, remember, Uma receives 4 votes, and then Paloma receives 3. So that means out of every 7 people that vote, 4 are voting for Uma, 3 are voting for Paloma. So out of those groups of 7, how many groups of 7 fit into those 217? That's what we're looking for. So for Uma, we have 4 out of 7. So we can say 4 out of 7 is the same as some amount over 217. So 7 times what is 217? Well, 7 goes into 217 31 times. So 7 times 31 is 217. So 4 times 31 is 124. So that gets us 124 per 217 votes. So Uma receives 124 votes. Same thing on Paloma's side. She's now 3 votes for every 7 people that vote. So to find that out, we say, well, how many times does 7 go into 217? Again, we know that's 31. And this time, 3 times 31 is 93. So she receives 93 of the votes. So to find the difference, just take 93 away from 124, and we get 31. Uma wins the election by 31 more votes. Now let's look at this application problem here. Vin has a recipe for a marinade. The recipe says to mix 3/8 of a cup of olive oil, a quarter cup of soy sauce, and 1/8 of a cup of lime juice. Sounds like really good marinade. How much olive oil does he need to make 9 cups of the marinade? And show your work. So let's see if we can pull some data out of this, and then we'll solve the problem and see what you can come up with. So try it, and I will be back momentarily. Okay, welcome back. So the first thing to realize is we can't find out how much he needs to make 9 cups of marinade until we find out how much marinade all these ingredients make together. So we got 3/8 of a cup of olive oil, a quarter cup of soy sauce, and 1/8 of a cup of lime juice. So we have to add those 3 things together and find out how much our total batch is. So we have 3/8 of a cup plus a quarter of a cup plus 1/8 of a cup. Now we know that 1/4 is the same thing as 2/8. So 3 plus 2 plus 1 is 6. 6/8. So we know that this makes 6/8 of a cup of marinade. We can find out how much you need for 9 cups of marinade. Now, because we're looking for how much olive oil he needs to make 9 cups of marinade, our answer is going to be in terms of marinade. So when we're setting up our proportion, let's say we're looking at oil per marinade. Okay, so we know we have 3/8 of a cup of olive oil per 6/8 of a cup of marinade, because we just found that. So if we divide that, we'll find out how much he needs for 1 cup of marinade. 3/8 divided by 6/8, which is the same thing as 3/8 times 8/6. Those two 8s cancel out, and we end up with 3/6, or 1/2. So 1/2 of what? What does that tell us? 1/2 cup of olive oil per every cup of marinade. Now we're looking for 9 cups of marinade. So it's 1/2 cup of olive oil for every 9 cups. Then all we have to do is take our 1/2 cup, 1/2 cup of olive oil, multiply that by the 9 cups that we need of the marinade. That gets us 9 divided by 2, which is 4 1/2. So 4 1/2 what? 4 1/2 cups of oil for 9 cups of marinade. So these are getting more difficult, aren't they? Let's look at number 2. Nina is listening to a song. It has a consistent beat. She counts 11 beats in 5 seconds. What's the constant of proportionality for the relationship of beats to minutes? Let's show your work. Give this one a shot, and I'll come back in a few minutes and see how you did. Okay, welcome back. This one's pretty easy. This is pretty easy, isn't it? We're looking for the number of beats per minute. But she's counting 11 beats in 5 seconds. So we have to figure out how to get from seconds to minutes. If there's 11 beats per 5 seconds, that means there is 11 fifths of a beat per 1 second. So we have a constant of proportionality of 11 fifths. So if we have 11 fifths of a beat per 1 second, all we have to do is have our 11 fifths of a beat times 60 seconds. That'll tell me how many beats in 1 minute. So 11 times 60 is 660. 5 times 1 is 5. You have 660 divided by 5. So what is 660 divided by 5? Well, let's find out. 5 goes into 6 once. There's 5. 1 left over. Bring down a 6. 5 times 3 is 15. 1 down. Bring down your 0. And 5 times 2 is 10. So we have 132. 132 what? 132 beats per minute. BPM. And there we go. So that's question 2. On to question 3. Davy goes to a carnival with 20 bucks. He spends 2 to get in, and the rest on ride tickets. Each ticket is $1.50. So how many tickets does Davy buy? And we have a multiple choice answer. Ooh, this will be good. And Bruno chose C as the correct answer. How might he have gotten that answer? So first of all, is Bruno right? And if he isn't, how did he get that way? So give this one a shot, and I'll be back in a few minutes with a solution. And we're back. How'd you do? The question maybe wasn't that difficult, but figuring out what Bruno did may have been. So let's see. If we go to a carnival with 20 bucks, we start off with $20 in our pocket. Now, it costs $2 to get in. So let's take off our $2 entry fee. We pay $2 at the gate. That leaves us with $18. That's $18 that we can spend on tickets. So how many tickets can we buy with $18 if they are $1.50 each? Well, that's just 18 divided by 1.5, right? So what is 18 divided by 1.5? Well, let's figure that out. If we have 1.5 and 18, we move our decimal over one place. That gives us 15 into 180. 15 times 1 is 15. That's 3 left over. Bring down your 0. 15 times 2 is 3. So the answer is 12. So how many tickets can you buy? You can buy 12 tickets. And 12 tickets is answer B. So if you got answer B, good job. So if Bruno chose C as the right answer, what on earth did he do? How did he get that wrong? Well, did you figure that out? The secret is right there, the $2 entry fee. If you didn't take out that $2 you paid at the gate, and you tried to buy tickets with 20 bucks for $1.50 each, then yeah, you'd buy 13 tickets, except you wouldn't because you'd never get through the gate because you didn't pay your 2. So that's where looking at the question, looking at those details really does earn dividends. Right? So good job on that, guys. Let's move over to page 95. We have a little clockwork question here. See how you do on this one. Gears A and B turn together. They're in mesh, right? Gear A turns 20 times when gear B turns 30 times, because gear B is smaller than gear A. So when gear A turns 60 times, how many times does gear B turn? So try that out, show your work. When we come back, we'll talk about it. Okay, welcome back. Let's take a look at what we've been able to pull out of this. So gear A is turning 20 times. Gear B is turning 30 times. Now you're looking for how many times gear B turns when gear A turns 60. So what let's do let's find our answer in terms of A, because if we can find out how many times gear B turns when gear A turns once, then we can find out how many times it turns when A turns 60 times. So let's do it like that. So what we'll have to do is work out gear B as a ratio per gear A. And that's pretty straightforward, right? Because we know that gear B is going to turn 30 times for every 20 times that gear A turns. So our unit rate between the two, that reduces down to 3/2, or 1.5. So that means that gear B will turn 1.5 times every time that gear A turns once. So we want to know what happens when gear A turns 60 times. How many times does gear B turn? So what we have to do is work out that ratio of 3/2 times for gear B turning gear A once, and multiply that times 60, because gear A is turning 60 times. That looks like this. Now, we can cancel some of these numbers out, right? We can say that 2 goes into 60 30 times. So that makes things a little easier. And 3 times 30 is 90, correct? 90/1. So that tells us that gear B turns 90 times for every 60 times that gear A turns, which makes sense if you think about it. Because if gear B turns 1.5 times what gear A does, if gear A is 60, 1.5 times that is 60 plus 30, which is 90. So checking the work, it works out. So gear B turns 90 when gear A turns 60. And there we go. So far so good, huh? These are kind of fun little number puzzles, aren't they? So let's move on. Let's look at question 5. In a certain town, we don't know what this town is. Maybe Gastonia, could be Belmont, could be Cherryville, who knows. In a certain town in 90 minutes, 1/2 inch of rain falls. It continues at the same rate for a total of 24 hours. Which of the following statements are true about the amount of rain in the 24-hour period? Select all that apply. That means more than one answer is going to be correct. So this doesn't just give you a straightforward answer. It's telling you how you set up the question, and you have to match that to the answer. Just when you thought this was going to be easy. Okay. So the number of inches of rain is 16 times 1/2. Or the number of inches of rain is 24 times 1/2. Or the number of inches of rain is 24 times 1/3. Or the number of inches of rain is 1/2 times 36. Or the number of inches of rain is 24 times 1.5. Some of these are right, some of these are wrong, depending on how you set it up. So give it a shot, work it out, see what you come up with, and we'll talk about the answers when we get back. Welcome back. So what we have to do first of all is figure out how to get that 90 minutes into 24 hours. Because we have 1/2 inch of rain per 90 minutes, but it's asking for the rate for 24 hours. So what we can do is we can find how many hours 90 minutes is, and then figure out how much that'll fit into 24 hours. So let's do that first. So we have 1/2 inch per 90 minutes. And that looks like 1/2 inch per 90 minutes. Okay, well, that's fine. Well, how many hours is 90 minutes? That's 1.5, right? So we can say it's 1/2 inch per 3/2 hours. Because 90 minutes is 1.5, and 1.5 is 3/2. Now, we know that if we're dividing 1/2 by 3/2, that's the same as multiplying 1/2 times 2/3. Aha. Those 2's cancel out. And we get 1/3. Okay, 1/3 what? Well, we've divided the number of inches by the number of hours, so that gives us the unit rate. So now we have 1/3 of an inch per 1 hour. Aha, good. So if we have 1/3 of an inch per 1 hour, how are we going to get to 24 hours? We go 24 times 1/3 of an inch. And that will give us what our answer is. So what is our answer? Doesn't matter. The question's not asking what the answer is. The question's asking what's the setup. And that's the setup. For one of them, 24 times 1/3. And that is C. So C is the right answer. C is one of the right answers. So let's see what other answer we can find. Now notice the way we did this is we found the unit rate per hour first and then multiplied by the number of hours. There's another way we can do this too. We can find out how many times does 90 minutes fit into 24 hours and use that as our unit rate. So let's see what that would look like. That would be a little different. Because let's say we have 24 hours and we're dividing that by 90 minutes. And we know that 90 minutes is 1.5 hours. So we're dividing 24 hours by 1.5 hours. And that looks like 24/1 divided by 3/2 again. So we can work that out. We can say, all right, so we have 24/1 times 2/3 because we're multiplying by the reciprocal. And, ooh, look at this. 24 and 3, we can cancel those. Because 3 goes into 24 8 times. And 8 times 2 is 16. So 16 what? 16 90-minute periods in one day. (16 periods per 1 day). So, okay, what does that tell us? That means every 90 minutes, it rains 1/2 an inch. And there's 16 of those in 24 hours. So if we multiply 16 times 1/2 of an inch, that will tell us how many inches we have in 24 hours as well. And 16 times 1/2, why, we have that. That is number A. So there's 2 that are correct. And how you find those. Now let's look at these others here. We're looking for 90 minutes, 1/2 an inch. I'm looking for the rate per 24. So would B work out? 24 times 1/2? That wouldn't work because 24 times 1/2 means 1/2 an inch in 1 hour. And then times 24 to get 24 hours. Well, 1/2 isn't the constant of proportionality there, because we're not talking about 1/2 in an hour, we're talking about 1/2 in 90 minutes. So, nope, cannot be B. How about D? The number of inches is 1/2 times 36. Well, how did we get the 36? Do you see how you get the 36? What you have to do is instead of dividing 24 hours by 1.5, if you multiply 24 hours by 1.5, in other words, if you forget to flip this reciprocal, if you multiply straight across, you'll get 36. So it's not 1/2 times 36. Can't be that. That's what happens if you forget to multiply by the reciprocal. And how about the number of inches is 24 times 1/2? 24 times 1.5. Well, that wouldn't work, would it? Because 1.5 isn't the amount of rain that's falling. That's the amount of 90-minute time spans. That wouldn't work because you're just multiplying 24 hours in a day by the 1.5 hours that are the 90 minutes. So you've messed up your constant of proportionality. You're not looking at the constant of proportionality for the rainfall. You're looking at it per the hours, and you're combining those. So now you're multiplying 24 hours times 1.5 hours instead of your units of rain. So that wouldn't work. So you wouldn't be E. So 2 correct answers, A and C. So if you got that, good job. That one was a lot of work to get to the answer. And if you got all that way, congratulations. Very proud of you. All right, number 6. Benjamin is planning to make scale drawings of bat wings. Why? I don't know. Just go with it. He is. He wants all of his drawings to use the same scale. He says he can use the equation D equals 1.5W to find the length of a scale drawing D based on the length of the bat wing W. What is the scale factor of bat wing length to scale drawing length? And explain. Explaining is the hard part. You may know the answer at the top of your head. Explain why. So try it out. Come back. I'll see you shortly. Okay, welcome back. Here we are. So if you see that equation D equals 1.5W, that should look really familiar to you, right? Because that's set up the same way as our y equals kx setup, right? Where we have the y, the constant of proportionality, and then the x. So if you fit that in there, the D equals 1.5 times W, you can see we're finding it the same way. So if we were going to graph this, we would say, because we can do that, because y equals kx works for a graph, so we can do that with D equals 1.5W as well. And we could say, okay, if x is 1, then y is 1.5. And your point would be there, and it would go through the origin, and of course the graph would be a straight line like this. And we know that we'd have 1/2 here, and we'd have 1 there. So our unit rate would be 1/2. Now we know that from our y equals kx setup. So because this is set up the same way, D equals 1.5W, and that's the length of the scale drawing based on the length of the bat wing, then yeah, that would be our constant of proportionality. That 1.5, because 1.5 to 1, because 1.5 to 1 is that constant of proportionality. So why would that be? Well, you could say that the scale factor, when you're making a scale drawing, is the constant of proportionality. Because if you're drawing something in scale, it's going to be proportionate. And because it's going to be proportionate, the ratio sets up exactly the same as it does as if it's a constant of proportionality in a graph, or a chart, or a t-graph, or any of that. Okay, let's move on to number 7. Asila and Carlos volunteer to fill gift boxes for soldiers serving overseas. Both work at a constant rate. They work together for 6 hours and fill 126 boxes. Asila fills 9 boxes every hour. How many boxes does Carlos fill every hour? There's a couple of steps in this one, right? Now, we know that. Let's pull some data first. We know that we're both working at a constant rate. We know they're working for 6 hours, and together they fill 126 boxes. Now we know how many boxes Asila fills every hour. So then we have to figure out how many boxes Carlos fills. So with that hint, see what you can do, work it out, and when you come back, we'll see what we can do with it. Okay, welcome back. How'd you do? Did you get it worked out? Let's see. We'll go over here to work this out. Now, we know that they both worked for 6 hours total. And they both filled 126 boxes total. And we know that Asila did 9 boxes in that 6-hour span of time. So it's 9 boxes times 6 hours. So if she filled 9 boxes in 6 hours, how many boxes did she fill? She filled 54 boxes in 6 hours. So from that, we can find out how many boxes Carlos filled, right? Because if they filled 126 total, and Asila filled 54, we can subtract those and find out that Carlos filled up what was left over, which is 72 boxes. Boxes, Carlos, boxes, Asila. So now we can find out how many boxes Carlos filled per hour, because we know how many boxes he filled and we know how long he worked. He filled 72 boxes per 6 hours. Divide that to find the unit rate, and you know it was 12, as 6 goes into 72 12 times, 12 boxes per hour. And that's the answer to that. How many boxes did Carlos fill per hour? 12 boxes per hour. Now let's move on to number 8. Amy is in charge of buying tickets for a trip to the movies. She can buy tickets at the theater or online. At the theater, 8 tickets cost $60. Online, 6 tickets cost $51. Amy needs to buy 24 tickets. How much money can she save by buying tickets at the lower price? Show your work. First of all, we need to figure out which is the lower price. So you find out the lowest price per ticket and then figure out where you go from there. Don't want to give too much away. Do your best, solve it. We'll come back, see how you do. Okay, welcome back. Let's see what we can do. Now let's pull our data out. We know that at the theater, 8 tickets are 60. And online, 6 tickets are 51. And we need to buy 20. So let's look at 2 different ways to figure this out. At the theater and online. So at the theater, we said that it was 60 tickets. No, at the theater, we said that it's $60 to buy 8 tickets. So that's $60 per 8 tickets. So $60 for 8 tickets is 8 divided into 60, right? And 8 goes into 60. Let's see, 7 eighths are 56. That's 4. Bring down your 0. 7.5. So that means it's $7.50 per ticket. $7 per tickets. All right. Now let's look online. Online, $51 buys you 6 tickets. So 51 per 6 tickets. And if you divide that out, how many times does 6 go into 51? That'll tell you your unit rate per ticket. So let's see. 6 eighths are 48. 3, bring down your 0, so it's 8.5. So $8.50. So it's $8.50 per ticket. So the first part of the question, which is the lower price? Buying it at the theater is the lowest price. The theater only costs you $7.50 a ticket. Online costs you $1 more. You go from $7.50 to $8.50. So it's costing $1 more per ticket. So how much can she save by buying tickets at the lower price? So if you're saving $1 from going online to the theater, you go from $8.50 to $7.50. So you're saving $1. And you multiply that by the number of tickets she's buying. She's buying 24 of them. That means she saves $24. A not insignificant figure for movie tickets nowadays. So there's question 8 for you all set up. Now question 9 is a little more open-ended, isn't it? Question 9 says, write a word problem that involves a proportional relationship and needs more than one step to solve, and show how to solve it. So this is up to you. You can make up your own. I'm going to show you how one works, and you can do something similar if you want to, or something totally different. So there's no right answer. We're just kind of making stuff up as we go. So let's come up with a problem and then see if we can solve it. So you're making fruit punch. The recipe calls for ½ cup of orange juice, ¼ cup pineapple juice, and ¼ cup apple juice. How much of the punch will you make if you use 3/4 cup of apple juice? There we go. Okay. So let's pull our data, see what we have. So we have a ½ cup of OJ, ¼ cup of pineapple, and a ¼ cup of apple. And we're looking for 3/4 cup of apple juice. So how much of the punch will you make? Well, first of all, you need to find out how much punch your recipe is going to make to begin with. And then you see we have a ratio here. If you're using 3/4 of a cup of apple juice and it calls for a 1/4 cup of apple juice, you're going to make 3 times as much punch altogether, right? Assuming everything else is in the same proportions. So let's figure out how much we're going to make altogether. So let's add all this stuff up. We have a 1/2 cup of OJ, 1/4 cup pineapple, and a 1/4 cup apple. No rum because you're minors. Okay. So we know that 1/2 is the same as 2/4. So we can say 2 plus 1 plus 1 is 4. So 4/4, which is the same as 1 cup. So your recipe calls for 1 cup of punch. Now you're going from 1/4 cup to 3/4 of a cup. So that means you're tripling your amount because you're going from 1 to 3. It's 1/4 to 3/4, but the ratio you're increasing is still 3. So you go from 1 cup times 3, and you go 3 cups altogether. And that's the way my personal version worked out. Your version might be considerably different, but that's part of the fun of math. You get to make up your own sometimes and see if it works out. So that's Unit 5. Thank you so much for joining me. I really appreciated your attention, and I enjoyed doing it. So I hope that this little series helped you, cleared up some misconceptions, or if you were kind of stuck on a couple problems, I hope seeing it from a different perspective than your usual teacher kind of helped you through it. So have a great day, and I'm sure I will see you in another lesson later on. Bye.